Hey physics group, we have video 3 here of our last waves part. So we're talking about Snell's Law for this video and how that kind of works. So let me pull up a little PowerPoint here. First I got this, see myself, there we go. It's kind of funny, you can do this, woo! Alright, enough of that. Here, alright, so we got Snell's Law. Basically what Snell's Law looks like, it's the proportion that if we can understand either both indexes or if we know both angles, we can kind of figure out the other parts. So it basically just tells us that we can tell what the refraction might be if we actually know what material it's going into, or if we know what angle it refracted at, we can tell you kind of what the index is, okay? So it's just a law to be able to help you with that. So I'm going to go to this little worksheet right here. Nope. Yeah, this one here. And kind of go through a couple questions here, okay? All right, so in this question right here, let's put it up just a little higher for me. Perfect. So basically here, again, Snell's Law basically works like this. N1 and sine theta angle 1 equals N2 and sine theta 2. So basically, again, multiply it, okay? Multiply it right there. So again, what the n is the n value of both, okay? And then I'm also looking at what's the angle of both. So for this one, I have the angle of both, and I have the n value of my first side. I want to know what's this n value. How hard is the energy or the waves? How hard is it to get through this material right here? That's what I'm looking for in this question, okay? So I have n1, so I have 1.5 times sine of 45. Equals, I don't know what N2 is yet, N2 unsure, times sine of 65. Okay, so went through this question, here it is here. Sine of 45 gives me 0.707, so we're just going to use 0.7, and then sine of 65, when I put that in my calculator, gives me 0.91. Okay, so I have 1.5 times 0.7 equals 0.91. Yeah, 0.91. Again, still times N2. I flip these around, doesn't matter. N2 is still there. All right, so I want to get N2 by itself. When I go 1.5 times 0.7, I get 1.06. 1.06 equals, again, this all again, times N2. Divide 0.91, cancel out, divide 0.91, and I get an answer of 1.16. So my N2 value equals 1.16. All right. And this kind of makes sense. I'll try and say this as best as I can, and this is going to stay the same for all questions. Anytime you have a higher index or something that is harder to go through, your angle is going to get closer to the normal. So that number should get smaller. So here I had 1.5. Here I had 1.16. So my angle should be bigger here than over here. Okay? Anytime your angle is bigger, your velocity is going to get bigger, your wavelength is going to get bigger, all that's going to get bigger, okay? Because it's easier to move in. Over here, again, our n value is bigger, so it's going to be harder to move in, so it's going to have a smaller angle. All right, so there's how you kind of do one question of that. I'll do one more question down here as well, talking about this. I have to actually get my protractor up for the next one, because it doesn't give me my actual angles, but there's example 1. Okay, let's go through example 2. On actually looking at this. All right, so if I go down a little, and I will zoom in a little more even. Let's do this first one here. So, actually I'm going to do B just because it's quite a bit different. So in this question it says N1 always has a refraction of 1. So that's really important to know. N1 here is just 1.0. But it gives you no angles, which means you, using your fancy Nancy protractor, have to figure this out. So I put it on the normal line. I look at it. I got pretty much exactly 45, 50. Not a big deal. I'm going to put in 45 here. It's kind of right around there. So I'm not going to be too big deal. If you use 50, again, I'm not going to be too crazy strict here. This one, comes around. Okay, and I get 30. That one's pretty on the dot for me, 30. All right. Once you've figured out the protractors and got your angles, then it's just back to that law. So again, back to N1 sine theta 1 equals N2 sine theta 2. So This is exactly the same. My n1 is 1, so down, I'll just put this right here, 1.0 times sine 45 equals n2, I don't know, times sine 30. All right? 1.0 times this is going to be exactly the same, so I'm going to finish the actual answer right here. This sine 45 is 0.7, sine 30 is 0.5. Okay, so that's right here. 1 times that is the same. So I have 0.7 equals n2 times 0.5. I go divide by 0.5 and divide by 0.5. So you can see the 0.7 from this sine 45, this 0.5 from sine 30, and then again, get it out. So when I go to 0.7 divided by 0. I didn't do this one. Where is my calculator? It's a good question. I should get something right around, again, I should get something right around 1.4, okay? So if I do that, I'll get something around 1.4. So this value, this will give me an answer, n2 equals 1.4. All right, so that's what my n value is for this one right here, 1.4, around that. Again, if you have something higher because you have a lower number here, like if you had 25 degrees or 20, and you get something like 1.7, 1.8, don't worry, I'll do the math for you, I'll figure it out, that kind of stuff. There's that last example of it. Oh wait, let's do a different type of example using Snell's Law on the same worksheet. All right, so if I do this, and if it's just a word problem, if I just have a word problem, how do I answer that? So I'm going to go to the bottom here. There's questions like this. I just want to go to the other worksheet because I like the way the other worksheet is kind of worded for one of them. So I'm going to do question 1 here on our other little worksheet. It's very similar to the question that you had on the other sheet. It's just I like the way this one's actually laid out. It says a ray of light traveling from air to crown glass is right up here, strikes the surface at an angle of 30 degrees. What will the angle of refraction is? So basically, in this question, it says n1 equals 1.0. We have sine theta 1 is 30 degrees. n2 is crown glass, which is 1.52. And we don't know what theta number 2 is, though. We don't know that angle. So let's set this up. Again, n1 sine 1, I'm just going to put it in here. So I have 1.0 times sine of 30 equals, unsure what the angle is, okay, times 1.52. All right, so let's actually figure out sine of 30 is 0.5. So 1 times 0.5 is 0.5 equals, still don't know theta, times 1.52 by 1.52 by 1.52. Okay, and what do I get? I have the answer for this one right here. Okay, I get 0.3, okay? Well, that's not an angle. Theta is not going to be 0.32. How I find this? You got to do your inverse of sine, okay? So your sine still has a big factor here, okay? So it says sine theta. How do I get that angle? You're going to go inverse, that little -1. So I'm going to go sine -1 of 0.32. When you plug that into your actual calculator, you'll get an angle up. Well, you give you a number, and that number is the angle. I get 19 degrees. So 19 degrees. Okay, so there's how to do this type of question where it gives you both n factors, like n indexes, and it's asked you to find the actual angle. What angles are going to come out at? So same formula, just I really want to emphasize, you're going to get a decimal. You have to make sure that decimal you go like negative inverse sign, and that'll give you the actual angle that outputs it. So hopefully Snell's law makes sense. Not too bad once you use it for a little bit. Yeah, it's pretty straightforward after that. So, okay, we got 1 or 2 more videos talking about how to draw some other things. But thanks, class. Hopefully Snell's law makes sense.